Find the area of the region R in the first quadrant bounded by the curves y equals x to the 2/3 and y equals x minus 4. So we definitely want to draw a picture so we can see what's going on here. And y equals x to the 2/3 looks something like this, and y equals x minus 4 would be up one over one, so it would be a line something like this. Now we need to figure out this point of intersection right here, and that would be when x to the 2/3 equals x minus 4. And I'm just kind of looking here, and I can see that that's going to work for 8 because we would have the cube root of 8 squared, which would be 2 squared, which would be 4, and that would equal 8 minus 4, which equals 4. So this point right here is going to be the point 8 and 4. Now, as we look at this, we are supposed to find the region in the first quadrant. So we're interested in this region R right here. So we've got to be careful, because if we went ahead and looked at making our rectangles here, this would not go clear down to this lower curve. It would actually just stop here, and so we've got to see from this point we would need to do two different integrals here. And if we don't want to do that, let's go ahead and see if we made our rectangles going this direction and had a little dy. So if we did that, we would have the integral from, we would need to see what y would go between, and that would be range from 0 to 4. And then our upper function, we would need to express that as x being a function of y. So right now we have y equals x to the 2/3. So that would mean y to the 3/2 would equal x. And then let's go ahead and express our second function as a function of x. So that would be x equals y plus 4. Now we can see that our line x equals y plus 4 is always to the right of our curve x equals y to the 3/2. So we are going to take the right function, y plus 4, and subtract the left function, which is y to the 3/2, and then we have our little dy. Let's go ahead and integrate that. So doing an antiderivative, we have y squared over 2 plus 4y, and then minus, let's see, power rule in reverse. It would have been 1 higher power. That would have been a 5/2, but we need the reciprocal of that power out in front, 2/5. This needs to be evaluated from 0 to 4. So putting in a 4, we'd have 4 squared is 16, divided by 2 is 8. Putting in a 4 here, we'd have plus 16. Putting in a 4 here, let's go ahead and write that out. So this would be putting in a 4, a square root, and to the 5th power. And then subtracting the lower limit, they all have y, so that would be 0. Now we can go ahead and simplify this, and we can square root the 4. And that will give us 2 to the 5th, which is 32, times 2, 64 over 5. So that'd be negative 64/5, and here we would have 24. So we can go ahead and make that into fifths, and it looks like we would get 56/5. Now this works, but there's actually even a better way to do this. This was smart to go to one integral versus two. It was easy to change our rectangles to go the other way, but let's have a look at an even smarter way. It's totally fine to use any geometry that you know. So if we looked at this region, we can see that if we dropped a line down here, that this piece right here is simply a triangle. It's very easy to find the area of a triangle. So what if we found the area under the curve between 0 and 8 of just this upper function, and then we subtracted off this area of the triangle? So let's go ahead and integrate from 0 to 8 x to the 2/3 dx, and that will give us this region right here, and then we'll figure out the triangle and subtract that. So we've got x to the 1 higher power. That would have been 5/3, and then we need the reciprocal of that power, 3/5, evaluated from 0 to 8. Move over here. That would be 3/5 multiplied by the cube root of 8 to the 5th. And the cube root of 8 is 2 to the 5th is 32. And 32 times 3 would be 96/5. Now we're going to subtract from that the area of this triangle, and it looks like it measures 4 by 4, so 1/2 the base times the height. So if we subtract from that 8, and of course if we make that fifths, we would get 56/5, just like we did before.